Hi, I'm Bob Tabor with LearnVisualStudio.net. I'm lovingly referring to this as the Cheater's Guide to XAML. In fact, I love it so much that I'm going to break it up into two lessons, part 1 and 2, just so there's twice as much fun. My aim for you is to get enough XAML under your belt so that the XAML that we see in the grid app template doesn't seem so intimidating, that you can make heads from tails of what's going on there. So sometimes you need to simplify in order to get clear and pinpoint whatever it is you're attempting to learn, and I want to do just that by creating a new project. And I want to make sure that I'm in the Visual C# Windows Store portion of the new project dialog. And this time I'm going to select the blank app XAML template, and I'm going to rename this to XAML Cheater and click OK. Alright, so I want to start at the beginning. We said previously that this code that we're looking at here looks an awful lot like HTML, right? It's actually XML. It's called the Extensible Markup Language. But more specifically, it's a type of XML that somebody layered on top of XML called XAML, or rather the Extensible Application Markup Language. XML looks a lot like HTML in so much that they share a common ancestry. Whereas HTML is specific to structuring a web page document's layout, XML is more generic. You can use it for any purpose, and you can define the names of the elements and the attributes to suit your needs as a software developer. Now, in the past, developers have used XML for things like app settings. We'll see that even here in our project in a little bit. Or using it as a means of transferring data between two systems that were never originally meant to work together. So developers get to decide on the rules for the XML, the meaning of the various elements that they invent. Now, a group of smart people at Microsoft invented this flavor of XML called XAML. As we'll learn about in a moment, it was created in an effort to make or allow you to create instances of classes, in this case, user interface objects like grids and panels and text blocks and so forth. And I'll explain the rationale why we needed this technology in just a little bit. So in a Windows Store app, we need to lay out user interface elements on a page. By default, the main page.xaml in the blank app template has an instance of the grid app or the grid class rather, for this purpose. So what I want to try to do first of all is add a little text to our page so that we actually see something on the page itself. And so I just begin typing away, and I think, okay, that's a good start, but wait a second, there's a blue squiggly line, and as I hover my mouse cursor over it, you can see that the property content is set more than once. And if I look here at the very top, the page has that same warning. And so each element in XAML has a single content property. For example, this page object, it has a content property, and we're setting the content property to what's ever in between the opening and the closing page tags. Now in this case, we're attempting to set that property twice. First of all, to the grid, and then secondly, to a text block. And we can see that's why we're getting the error message. And that's not allowed in XAML. You can only set the content property or attribute one time. But there are a couple of controls like the grid control and the stack panel control, which we'll meet in a little bit, and their only purpose is to allow you to add multiple controls inside of their definition or their bodies. And that will allow us to determine how items inside of those controls are displayed. The grid allows us to define rows and columns, and then we can use that to specify which cell a given control, like our text block here, should live or sit inside of. So let's do this. Let's take our text block, and we're going to hit Control X on our keyboard, and then we're going to use our arrow keys to go up and paste it right in between the opening and closing grid definition. And you can see that we do see the word Hello World. Let me actually make that larger. We can now see it in the upper left-hand corner. All right, that works, but this is a grid, right? And there's supposed to be rows and columns. Where are my rows and columns? Well, by default, a grid has one row and one column. Also, by default, any control that's placed inside of a grid will be placed, again, by default, in the first row and the first column of the grid, unless you tell it differently. And so we're going to do that in just a moment. And so we'll see a lot of embedding of objects inside of other objects, inside of other objects, and that's really normal. And you know, when you see that type of embedding with indentation level and so forth, it suggests a relationship between those objects. Sometimes that relationship is for layout, and sometimes it's for setting properties or attributes. Now, here's a case where we're going to see how we can set complex attributes of the grid by creating child elements of the grid. So let's do this. We're going to create, right beneath the grid's definition, we're going to go grid.row definitions, and then we're going to create grid.column definitions. And so let's create 3 rows and 3 columns. So we're going to start off with a row definition, and in order for this to be meaningful, I'm going to give each row a height. And I can specify the height in a number of different ways. The first way is to give it an absolute pixel count. So in this case, I want it to be 140 pixels tall. The second row, I'm going to create the height and set it to auto, which means it's going to look at whatever is contained inside of that row, and it will adjust the height of that row based on what value it needs to fully render the items inside of that row. So if there's something very large, it'll make the row larger. If it's something very small, it'll adjust the height to accommodate whatever's inside of it. Okay? And then the third way that we can set a row definition's height is to just give it a relative value of the asterisk. And the asterisk means give me a portion of whatever is left over, whatever remains. So after we've allocated 140 pixels to the first row, and after we have decided whatever the height of the second row should be, then take the remainder of that and set it equal to the height of the third row. And so let's build on that idea when we work with columns. Now the columns work the same way. We can set the column's width, and we can set it to a specific number like 140, but what I really want to do is use to build on this asterisk idea. In fact, I'm going to create 3 columns, and if we were to zoom out to 50%, you can see the little guidelines that are available. And so it appears that we have 3 columns of equal width. But what I can do in front of one of the asterisks, like the second column, is to put a 2 in front of it. And that means give me a double portion. So instead of thirds, now we're dealing with fourths. We're saying give me 1 asterisk, 2 asterisks, and 1 asterisk, as you can see the little note above it. And then we can further add some width to our third column by putting a 3 in front of it. So we're basically saying give me 3 times my portion, or the normal share. So here's 1 times, 2 times, 3rd times. So now we have, what, I guess sixths, right? And so that's how you can use the asterisk to assign widths or heights along with auto and specific pixel counts to create the sizings for various things like columns and rows. And so now what if I want to move this text block, which we said by default is going to sit inside of the first row and the first column because we didn't specify anything. What if we wanted to move it to the second row and the first column? All right, so in order to do that, we're going to grid.row equals the second column, 1. All right, you're saying, wait, the second column should be 2. No, it's 0 based. So the first row rather will be 0, the second row will be 1, the third row will be 3. Same thing with columns. And if I wanted to move this, for example, all into the center, I would go grid.column equals 1. And now it's in the center cell. All right, so what about this syntax that I've just used? Now, this may not look like anything you've seen in HTML or some other markup language. Well, the grid.row and the grid.column is featuring something called attached properties. The property row and the property column are actually defined by the grid. But you can set these as an attribute of the text block because of the relationship that the text block and the grid have with each other. The grid owns the text block in a sense. So this is the main use for attached properties, to enable child elements in a markup structure to easily report information back to its parent. In this case, it's like my child saying, hey dad, put me in column 2, row 1. And so I take you and I put them in column 2, row 1, or column 1, row 1, okay? And so that's really what's going on here. Okay, I said a little bit ago that I would explain the rationale behind XAML. I think I can make a case for why we need XAML. What I want to do is add some attributes to this text block. For example, I'm going to set its height equal to 23. I'm going to set its horizontal alignment equal to left. Let's live life dangerously and set it to right. Okay, you can see it moved over to the right side of column 2. Let's give it some margin, and margin's just like a space between it and whatever else comes around it. So in this case, we're going to say move it 70 to the left. From the left, we're going to send it 45 from the top, and then 0 and 0. All right, so these numbers basically indicate the amount of area from the left, and then from the top, from the right, and from the bottom. And you can see it's moved it down 45 pixels from the height or the top of the column, and then have moved it 70 pixels. Let's make that from the left. Since we have changed the horizontal alignment here, let's put it 70 from there. All right, you see it jumping over to the left, okay? And then 0 from the bottom. Great. And then finally, let's give it a name of Hello World. Okay. And just so we can see this, sometimes you'll see these formatted out on each element, or attribute rather, of the element onto its own line. Okay, like so. But take a look. It created one line of code essentially in order to create this instance of text block. So the first characteristic of XAML is that it's a succinct means of creating instances of classes. In the context of building a Windows Store app, it's used to create instances of user interface elements. However, XAML is not just a user interface technology. It could be used for other purposes in other technologies. But the key here is that we're creating an instance of a class called text block, and then we're setting properties on that instance of that class. All right? So just to prove that it can be done, what I want to do is write C# code to create the exact duplicate of this, except in the row or the column next to it, okay? Just to show you how much effort it would take to do this in C#. And to start this process, what I want to do is give the grid a name. And so I'm going to type x:\name, and I'll explain why the x in just a bit. And I'm going to give it a name of layout grid. All right, so now we can access it programmatically in our C# code. And here's a tricky little idea. If you've never programmed with Windows Forms or ASP.NET Web Forms, this XAML page actually has an arrow next to it. And when I click the down arrow, it'll show me another file named mainpage.xaml.cs. And I'll explain the relationship in just a little bit, but follow along for now. Here what I want to do is I want to create another text block, an instance of the text block class. And now I'm going to start setting properties like the name property, the height, and I think we want to set the horizontal alignment equal to right, and then we're going to set that margin. There we go, 0, 45, 70, 0. I think that was what we used previously. We'll change the text in here. We'll write something different so we can tell the two apart. Hello from the .cs file. And I think that's all we're going to set on this guy. And then what we'll do is add it now to the grid. And so we're going to go layout grid dot children dot add, and we're going to put our text block 2 in there. Whoops, text block 2. And then we want to set on the grid, we want to set the row text block 2, and we're going to put it in row 1, and then we're going to set grid dot set column, and we'll put it in column 2. All right, so now let's run the application and see what we get. There we go. Now let's run see what we get. Okay, so you can see it's essentially the same. The settings are the same, but look at the amount of C# code it took to recreate what we were able to do in just a few little succinct attribute settings. It took a lot more C# code, and this is a simple case. You can imagine if we were doing something a bit more complex. So I think that is the main case of why you need XAML. We wanted a way to create instances of user interface elements, a way that already seems natural so that there's not a large learning curve, and if you're already familiar with how to lay things out in HTML, there will be some transfer over, even though what's going on behind the scenes is dramatically different, right? But you can feel that it feels roughly equivalent, and I think that ultimately it takes a lot less code to accomplish what you're trying to accomplish using XAML. All right? But here's another head scratcher. I said, hey, just ignore the fact that these two files are related somehow, as you can see in the Solution Explorer. They're even almost named identically. So what's the relationship between these two files, and how is it that we were able to write code here in this onNavigated to event handler, and then without really indicating that we wanted it to show up in this main page.xaml, how was this text block automatically placed here on the designer? Here's one clue. Take a look at the declaration for this class. Here we have a declaration for main page, and it's a class, and it's a partial class, and it's of type page. Now take a look at the definition for main page.xaml. If we look at the very top, we can see it's a page, and its class is set to XAMLcheater.mainPage. This namespace is XAMLcheater, so it's XAMLcheater.mainPage. All right, and so the partial is really the key here. This means that the compiler will combine the output of the main page.xaml and the main page.xaml.cs into a single class. This means that these are two parts of a whole. And that's an important concept, that the XAML that we create declaratively, like what we see here on screen, gets compiled into the intermediate language just like C# gets compiled into intermediate language. And they're both partial implementations of a single class. So this allows you to create an instance of a class in one file and then access it using another file. And that's exactly what we did when I added the name attribute to the grid. I was able to then access it programmatically here in my code. All right, pretty cool. So hopefully that sufficiently explains the relationship. We'll be doing both, writing C# code to make things happen, and then also writing XAML code to design the user interface and keep those separations, those concerns separated from each other. All right, so let's get back into this and talk about layout a little bit more. I said that there were several objects that could be used to define layout. Grid was just one of them. The two that you'll see most often is the grid and something called a stack panel. A grid defines columns and rows like we just saw. A stack panel will take any items that are defined inside of it and will stack them either horizontally or vertically. And so these layout controls have one purpose: to control the display of one or more controls or items that live inside of them. And we're going to use a lot of grids and stack panels to construct the various parts of our user interface. But most of the templates have the grid as the outermost layout, like we see here in our blank app template. Again, you're going to need several stack panels and grids that live inside of other stack panels and grids that live inside of yet other stack panels and grids in order to get the layout that you really want. And so what I'd like to do here is take a moment and define another grid that will live inside of this grid. And we're going to put it inside of one of these cells. We'll put it inside of this, this column 2, row 3. Okay? So let's go down here, and this is an important concept to begin with. We're going to create another grid, and we're going to set the grid's row, and we're not setting it for itself, we're setting it for its parent. The grid lives inside of a grid, so we're saying put this grid inside of that grid's row 3, column 2, right? And so now we can see it right here in our cell. And we want to define additional row definitions and column definitions. And we're going to make this simple. What we're going to do is show how to create a simple form that you might like to use for user interface input. And there won't be much of that in the remainder of this series, but I do want to show you just how a grid can be used inside of another grid and get that idea firmly nailed down in your mind. And so we're going to create several of these rows and then a couple of columns. Great. So let's just focus on that. Okay. And so now what we're going to do is start off with the text block, and we're going to say text equals name. And we're not going to set its row or column because by default it'll sit in the first row in the first column. But with the text box, we're going to set its column equal to the second column. And so now we can see the beginnings of a form. In fact, let me get a little bit closer here. All right, you can see that the text box we defined takes up the entire width of the column by default. And here, what we want is in the second row, first column, we want it to say address, and then we're going to add a text box. Okay. And then finally what we want to do is add a button control. And we'll set that in there. And we want to set its content equal to go. All right. So there we have a simple example of how we can put a grid inside of another grid, the layout grid, to achieve a more complex layout, and we'll be doing that often. So that is how we'd use the grid. Let's take a look at adding a stack panel, and this will be a real simple, quick example. Here we're just going to create a number of buttons. Whoops, buttons. And we're going to set its content equal to first button and so on. So let's move over to the right here, because I'm going to put this in grid.column equal to grid.row equal to. Great. And so then here, let's just copy a number of these and change the content. All right, and we can see that they line up by default vertically. Now if I want to change, I can change them the orientation to horizontal. You can see now they line up horizontally. You say, well, where do they go? Well, they align themselves to the middle of the height, the entire height that's been given. So if we want to put them back towards the top, we're going to set another attribute, the vertical alignment, and we're going to set that equal to top. Now they jump back up to the top of the given cell. Great. And I think the moral of the story right now is that we can achieve just about any layout that we want by using either a grid or a stack panel, and then by using this attached property syntax to declare or to request which column and row that each given user interface element wants to be placed inside of, telling its parent, hey, put me here and put me here. Okay? Okay, so I think that's enough for one lesson. Take a quick break, then we're going to come back and add on, layer on some more information about XAML in the next lesson. All right, we'll see you there. Thank you.